Are we alone in the universe? The truth may be closer than we think. For centuries, humans have stared up at the stars and asked the same question: are we alone? In a universe filled with trillions of stars and untold billions of planets, how could Earth possibly be the only place where life emerged? It sounds arrogant, even absurd. And now, thanks to decades of scientific breakthroughs, from NASA's Kepler telescope to the eerie silence of the cosmos, the question isn't just philosophical, it's scientific, it's urgent, and the answer may be closer than we ever imagined. Let's start with the math. Our home galaxy, the Milky Way, contains roughly 100 billion stars, and based on recent data from the Kepler mission, we now believe that nearly every star has planets orbiting it. Many of these are rocky, Earth-sized worlds, sitting in what's called the habitable zone, the sweet spot where temperatures could allow liquid water, a key ingredient for life. When we extrapolate those findings, we get a staggering estimate. There could be as many as 1 trillion potentially habitable planets in our galaxy alone, and that's just the Milky Way. The universe contains at least 2 trillion galaxies. If even a tiny fraction of these planets developed life, there should be civilizations scattered throughout the cosmos. So, where are they? That's the essence of the Fermi paradox, named after the physicist Enrico Fermi, who casually asked over lunch in 1950, "Where is everybody? If intelligent life is common, why haven't we heard from anyone? Why don't we see giant alien megastructures, spacecraft zipping between stars, or even just a whisper of a signal?" The silence of the universe isn't just puzzling, it's haunting. It suggests either we're the first or we're already too late. To answer that question, we turn to one of the most famous equations in astrophysics, the Drake equation. Developed by Frank Drake in 1961, it's not a mathematical formula with a clear answer. It's more like a framework. It asks, how many civilizations in the Milky Way are capable of communication? The equation considers factors like the rate of star formation, the fraction of stars with planets, how many of those planets are habitable, how often life actually begins, how often it becomes intelligent, and finally, how long those civilizations last. The big unknown? That last part. Longevity. Even if life is common, maybe intelligent civilizations don't survive long enough to make contact. But humans aren't just sitting around waiting. In fact, we've been listening. The effort to detect alien life got serious in the 1960s with the birth of SETI, the search for extraterrestrial intelligence. It started small, single-dish radio telescopes scanning narrow portions of the sky. But over time, it grew. Today, SETI includes vast networks like the Allen Telescope Array in California, 42 dishes working in unison to sweep across the cosmos for narrow-band, non-random signals. These aren't just random blips or natural space noise. SETI scientists are looking for something very specific, a focused artificial signal that stands out against the background chaos of the universe. And sometimes, they find something they can't explain. In 1977, a volunteer for SETI named Jerry Amon was analyzing data from the Big Ear radio telescope in Ohio. What he saw stunned him, a powerful radio signal lasting 72 seconds, coming from the direction of the constellation Sagittarius. It was so clean, so structured, so perfectly narrow band that Amon scribbled a single word in the margin of the printout. Wow. Ever since, the W signal has become the most famous mystery in SETI history. It never repeated. We've never heard it again. But we also couldn't explain it. It wasn't Earth-based interference. It wasn't a known celestial event. To this day, it remains an open question, possibly the first message from an intelligence not of this Earth. But the WOW signal wasn't the only strange blip. Over the years, SETI has detected other one-off anomalies, some later explained, others still debated. One particularly curious case came from the SETI at Home project, where millions of volunteers lent their computer processing power to scan data from the Arecibo telescope. One candidate signal, named SHGB02+14A, was detected twice from deep space and showed a structured pattern. It, too, remains unconfirmed. But these moments spark a recurring hope. What if we're on the verge of a real signal? One that not only repeats, but that we can decode. It's not just about listening. Humans have been sending our own messages into the void for decades. In 1974, scientists beamed the Arecibo message toward a star cluster 25,000 light-years away. It was a simple, binary-coded description of humanity. Our DNA, our solar system, a stick figure of a human, and basic math. In 1977, NASA launched the Voyager spacecraft, each carrying a golden record designed by Carl Sagan. These records contained greetings in 55 languages, music from around the world, and images of Earth's people, landscapes, and culture. If Voyager is ever found, it would be like an interstellar message in a bottle. But that raises an unsettling question. Should we be announcing ourselves at all? Not everyone agrees we should. Stephen Hawking famously warned against shouting into the cosmos. His fear was simple. What if the first civilization to hear our message isn't benevolent? What if they're thousands or millions of years more advanced and view us as ants, not allies? After all, when humans discover new lands, history shows we don't always come in peace. Should we expect aliens to behave any differently? But others argue it's already too late. Earth has been leaking radio and TV signals into space for nearly a century. Any civilization with the right technology, and within 100 light-years, already knows we're here. Shows like I Love Lucy and the first moon landing are already streaming across the galaxy. So the real question isn't whether they know about us, but why they haven't answered. That brings us to the Fermi paradox's most disturbing solutions. Maybe they're out there and ignoring us. Maybe we're too boring, too primitive, or too violent. Maybe they're avoiding contact because they know how dangerous it can be. Or maybe civilizations just don't last. The moment they invent nuclear weapons or climate-destroying industries, they wipe themselves out. Perhaps the universe isn't quiet because life is rare, but because intelligence is self-destructive. But there is hope. Today, the science of astrobiology is advancing fast. New telescopes like James Webb and the upcoming LUVOIR will be able to detect the atmospheres of exoplanets, searching for signs of life like oxygen, methane, and water vapor. SETI itself predicts that within 20 to 30 years, we'll either receive a signal or have enough data to know whether intelligent life is out there. And here's the deeper truth. Discovering intelligent life would answer more than just, are we alone? It would prove something far more profound, that it's possible to survive. If we find a civilization that's been broadcasting for thousands of years, it means someone made it through their version of the 21st century. Through nuclear tensions, climate disasters, pandemics, and technological upheaval. They didn't destroy themselves. They endured. And that's the message we need most. Not just that we aren't alone, but that it's possible to grow old. So maybe the real reason we search the stars isn't curiosity. Maybe it's hope. Hope that in the vast, cold silence of the universe, there's someone else out there. Someone watching, listening, waiting. Not gods, not monsters, just neighbors. And one day, maybe not too far from now, we'll finally say hello.